Hey, this is Dave with OC Astronomy, and welcome back. We're going to look at Chapter 10 of OpenStax. Chapter 10 deals with the planets Venus and Mars. Chapter 9 had Mercury and the Moon, which were both very similar. Now we're looking at Venus and Mars, and they are actually very different. Venus is a lot larger and Mars is smaller. Venus has an atmosphere and Mars doesn't, and there's lots of differences to look at. One thing about Venus, though, is very intriguing, is Venus is a very close twin to Earth in a lot of respects. Venus's mass is about 8/10, so it's almost the same amount of mass. Its surface gravity is about 0.9. So if you were on the surface of Mars, the gravity would feel about the same. One thing, though, that's really different is Venus has a really thick atmosphere, and it's made up of like volcanic gases and carbon dioxide. And so Venus actually has an atmospheric pressure. It's really, really strong. Whereas Mars' atmosphere only has about 7/1000ths of Earth's atmosphere pressure. So Mars's atmosphere is very, very thin compared to the thick atmosphere that's around Mars. Because of that thick atmosphere, we've tried visually to look at Venus, but with all the clouds there, you can't really see the surface. And so one of the interesting things Galileo looked at, and he could only see like a pale disk. He noticed that the disk did undergo phases. So as compared to where we were looking at it and where it was in the sky, Venus did go through certain phases, similar to the moon's, but the phases indicate that it was going around the sun instead of going around us. And that was one of the first proofs of the fact that the Earth might be also going around the sun. So Venus is really important to study, but looking through its atmosphere is really hard. We've sent about 50 probes to Venus trying to learn more about it, but we've only had about half success rate, so about 25 of those have either crashed or didn't make it and didn't provide us the information. But we have had about 25 probes, and when I say we, there's been a couple from the United States, but most of the probes that have gone to Venus were sent by the Soviet Union. The Soviet Union and Russia were very successful in sending probes to Venus. That was one thing they did better than the United States space program. One of their probes landed and was able to last about 23 minutes. It went through the surface, through the atmosphere, and landed on the surface. Was able to spend about 23 minutes there before it literally melted. But in that time, it was able to rapidly take some pictures of its surroundings and beam those pictures back to Earth. And we picked up the radio waves from them that transmitted the pictures. And so we were able to actually, for the first time, because of this Russian spacecraft, we were able to see the surface of Venus. Since then, we've had a very successful mission from the U.S. that went a lot later than the others, but a U.S. Probe called Magellan. Magellan went and it circled. It didn't land on Venus. It circled it, but it had something called radar imaging, and the radar imaging was able to pierce through the clouds and look up the surface of Venus through the radar waves that bounced back. Because it was able to see that, they were able to see a lot of craters, and the thick atmosphere of Venus ate up most of the small impacts that it would have gotten, but the larger ones made it through. And a lot of times they'll find craters, large craters, in multiples of 3 or 4, because as a really big rock goes through the atmosphere, it'll heat up in the Venus's atmosphere, and it'll break up into 3 or 4 chunks and then smash into Venus. And so you'll get 3 or 4 impact craters that are all in the same area, and they're all really big because they all came from one impact. And because of that, they've been able to see that the new ones are in the fresher layers of Venus, and Venus's only the newer ones are around, and the old ones are all filled in with lava. Venus has a very active volcanic stuff going on. There's a lot of tectonic activity. The crust of Venus is being pushed and pulled by the volcanic and tectonic activity. And so a lot of the older craters are just all filled in with lava, and they don't think that any of the very much of the surface has very many new impacts. Almost all of them are old. Because of the volcanic activity and all the stuff going on there, there's something on Venus called the Runaway greenhouse effect. And what that means is the atmosphere gets warm because the greenhouse gases trap the light from the sun, and that warm atmosphere in turn heats up the planet and can cause more volcanic activity, which then puts out more carbon, which then traps more gas, which then heats up the planet, which then puts out more carbon, which traps more gas. And so it's this runaway cycle, and the surface of Venus has gotten really, really hot. Now, contrast that with Mars. The surface of Mars is actually really quite cold, and the atmosphere is really thin, and it's a lot smaller than Venus. And one of the consequences of Mars being quite a bit smaller is that it has a lot weaker gravity. As we mentioned, it has about half the gravity of Earth, or actually 4/10 of the gravity of Earth. And it's a lot smaller. So it doesn't have a lot of gravity to hold onto its atmosphere. Now, they've been able to send some robotic probes to Mars. We haven't landed any people there yet, but we've also sent probes. And also, similar to Venus, we've only had about a 50% success rate, which means that we tend to lose about half the probes we send to Mars, which we kind of want to get better at landing stuff like that before we try to send humans, because we don't want to send humans with a 50-50 shot of landing, right? And so for now, we're sending still robots. One thing they've found is when they've landed these probes is there is evidence of water on Mars, and especially water that was flowing at one time, which means there was a lot more of it. NASA has landed a couple of probes called Spirit and Opportunity. They landed at two different locations near the same time, and they were both kind of roving around at the same time. And they were kind of small rovers, about the size of a desk, maybe about that size. And they did some cool stuff. Opportunity went down into a crater and then nearly didn't make it back out again, but it slowly crawled its way because its wheels kept slipping in the sand. And one thing they found on Mars is it does have a very sandy surface. Every year, there's a big dust, every Martian year, there's a big dust storm that engulfs the entire planet in dust, and then it'll settle down for a while. Actually, one of those times it happened, Opportunity was starting to get low battery because of the dust that was on the solar panels, but the big windstorm actually blew the dust panels clear and gave Opportunity a recharge for a while because its solar panels were active again. And so those two sent back a lot of pictures. Lately, though, we've had another probe called Curiosity, and it was only supposed to last about 6 weeks, but the Curiosity rover has survived for over a year, and it's been sending back a steady stream of pictures, and they've made a ton of discoveries there. One of the things they can do with that rover is they have a drill that drills into the rock and then drills back out of the dust samples, or the rock samples that it gets from drilling. It picks up with a robotic arm and puts on a tray. The tray goes into a little easy bake oven that hits it with lasers, and the lasers heat up the rock and burn it. Now, when it burns that rock or causes that rock to go into little fine particles, then it shines a light through it, and you can take the spectrum of those rocks and see what's in there. By doing that, they've been able to tell exactly what the rocks are made of. They've found a lot of the rocks are basalt type of rocks that you get from lava. So there are a lot of lava rocks. Then there are also a lot of limestone type rocks that you get with running water. And so they know some of these rocks are the kind of rocks that only form really whenever water is around. And so they know in its ancient past, Mars did have water in it. And then also in those samples, some of them have been able to zap and find traces of liquid water of ice water that's in there. They're able to know that below the surface of Mars, there probably is a lot more water trapped in underground caves and stuff like that. And it's likely to be salty, briny water. But on the surface, there's not much. One of the consequences of Mars being small and not having a strong gravity is it couldn't hold onto its atmosphere as well. It also doesn't have as strong of a magnetic field, and so it doesn't have the magnetic shielding like Earth does of that from the solar winds. So the solar winds hit Mars directly, and there's no magnetic shield to keep it from impacting. So the solar wind hits Mars, and as that steady stream of solar wind keeps hitting it, it actually knocks off any particles that would be in the atmosphere, because you have these super high velocity cosmic rays or solar particles, solar wind that hits it and knocks those particles off the atmosphere. So any thin atmosphere that might have been there in the past has now kind of evaporated off of Mars. And because of that, instead of a runaway greenhouse effect, you get something called a runaway refrigerator effect. So the fact that it doesn't have an atmosphere means that the surface is really, really cold. And then it gets even colder, because what happens is the water that might have been in the atmosphere, it all condensed down and formed like snow on the polar caps of Mars. It has like a crust of snow that's made out of water ice and carbon dioxide ice. And because that precipitated out of the atmosphere, it made the atmosphere even thinner, which meant that it got even colder. So because it thinned the atmosphere, you got colder and colder and colder. Whereas with Venus, the atmosphere got thicker and it got hotter, so it got hotter and hotter and hotter.